Okay, this video is a revised video of troubleshooting the advanced drive system using W2000 Diagnostics. I received a suggestion to change this window to name it pulse width modulation percent, and I felt it was a good suggestion. So we're going to refer to it as PWM percent right now. Something else I'd like to mention is I'd like a group of people. If you're knowledgeable about workings, you've been around W2000s for a while, and you want to suggest something about the program or the pop-ups that you're going to see later, definitely want you to do so. We're definitely open to suggestions and contributions of anything that you've experienced out in the field. So right now we're going to show a normal forward situation for the advanced drive system. You'll see here that this window is showing the actual milliamps going to the advanced drive pump, and it is 62.6. It's going to vary. The engine's not running. It's going to vary a little bit, but this really isn't very important in a normal situation. It's very valuable when troubleshooting, which I'll demonstrate later. But this is what you'll see in a normal machine forward propelling situation. You'll see here the engine's not running right now. You'll also see this window here is the milliamps going to the PRV valve, which is also referred to as the DV1 valve in the schematics, or it's also referred to as the high-low shift valve. This, like I said, is just a normal propel situation. Now I'm going to bring it back into neutral, and we're going to create an open circuit. This demonstration is going to show as if there was a broken wire going out to the plug on the propel pump, the advanced drive pump, or a bad plug, or an open coil on the pump. Now this is where this window becomes very valuable. You see right here that the controller is giving a full output. The reason the PWM increased over the other value is because it's not getting anything back. It's not reading milliamps coming back. So it's ramped itself up to a full output. If you are troubleshooting the advanced drive system and you see a condition like this, this is what you'll see with an open circuit. And like I said, there could be broken wires, a bad plug, the coil could be open. Alright, now we're going to simulate a intermittent situation. You see how it comes right back to where it should be. If you're seeing this value on the left go drop to 0, this one ramp up to 100, you've got an intermittent open circuit. Now I'm going to bring the machine back to neutral, and this, in my opinion, is probably the most valuable use of the software, is a short circuit situation. Okay, right now you've got a short, and watch what happens. Okay, notice that the milliamps are varying. It's very erratic, but here's the key right here. The PWM is still at max condition. It's still giving a full output, and the milliamps to the pump are varying. They're all over the place. This is what you'll see if you've got smashed wires, a shorted coil, or a shorted plug. The milliamps are going to vary. They're going to be lower than they should be, but your PWM is going to be at full. This is a full output condition. Now I'm going to bring it back to neutral, and we're going to put everything back to normal. We're back to a normal condition, showing the output to the pump, and the PWM is back down to 62.8. Now this number will change if you go into the CGC under the hydraulics menu and change the min or the max current going out to the advanced drive pump, this value will change. So this number is generated and it's based on what the CGC settings are. This is what you're reading right here. I'm going to go back to neutral and create a very common condition, which you'll see with these machines. If you watch the right joystick, the neutral, I'm going to try to create a bad neutral safety switch here, right there. See how the 3 micro switches are all red and the drum clutch enable went false? Very common for that neutral safety switch to fail. The machine will not move. You can't move this machine, and nor can you turn the cutter on. This is something you can see instantly without getting your multimeter out or having to troubleshoot this circuit. All this information that you're seeing right here on this page would take quite a while to gather using a multimeter or a test light. Now I'm going to start the machine. What's going to happen is when I start the machine, the CAN bus is going to stay active for a short period of time, and then we're going to lose communication. The CAN bus stayed active long enough for the engine running to go true, and we got a value here in the track pressure. Takes about 13 seconds for the bus to reset. Okay, we're back online. CAN bus is reset. This is the track pressure value, which the machine's not moving forward, obviously you can see, but this value right here is your charge pressure. I increase the engine speed, so if you suspect a hydraulic problem in the advanced drive circuit, you can easily check charge pressure right here. Notice these labels over here, engine speed increase. I'm gonna idle the engine back down. You'll see the decrease go true and the corresponding output go true. And the drum clutch enabled was true. Notice when I increase the engine speed too high to engage the clutch, the availability to engage the clutch goes false. When I idle the engine back down, now I'm going to stop the engine. You'll see the stop engine input, corresponding output go true. And you'll see the stop output is held on to ensure the engine does come to a stop, and then once it goes false, the start enable goes true again. Regarding the condition with the neutral safety switch, let's say that you encounter that problem. If you want more information, anywhere on the program that the arrow turns to a finger, it means there's more information available. So if you click on this, you'll see that switch is 12S1 on page 12 of the schematics, and the switch can be replaced without replacing the entire joystick. You'll find these mechanics tips throughout the program. Right here, like the side plate lower circuit is not controlled by the Wirtgen controllers, but there's a very detailed pop-up giving you the switch numbers and the entire path of the circuit. And I'll just give you a quick view of all the pages. Controller 1, Controller 2, Controller 4, in the same situation, pulse width modulation, milliamp output. Controller 5, just demonstrating the rear steering to the right. And page 5 is engine data. So hopefully this video will help you troubleshoot the advanced drive circuit. Thanks for watching.